Restream is saying connecting. We could be, okay, now we should be live. Hello everyone, welcome to rastgele's 71st talk today. So today I'm really happy to host Timo de Wolff. And today's topic is going to be about interdisciplinary research and how to do it, where to find interdisciplinary researchers, basically. And before we start, maybe I should a little bit mention about me and Timo's relation and like how we got to know each other. So we know each other like since 3 years now, and he happens to be my PhD advisor, and so we are basically working together for 3 years, and in these 3 years we had the chance to do a couple of projects, and one of these projects was like quite applied and everything. So, but like not only this, but on the other hand, Timo has lots of other applied projects. So I thought it would be a nice idea to invite someone who has already delved into this waters of interdisciplinary research. And on top of this, Timo is a member of Junge Akademie'nin, so which is a organization which is an organization centered in Berlin. I'm quite sure that he will mention he will tell us about Junge Akademie a lot more. But basically, in there, he's in contact with scientists from lots of different areas, and he will tell us how the stuff goes when multiple disciplines come together. So without further ado, again, welcome Timo, and maybe we can slowly start by you introducing yourself. So what are you doing now, and how did you end up in what you are doing at the moment?
However, the group I was located in, my advisor, Thorsten Theobald, had some quite connections to applications already, in particular to optimization.
Oh, sorry, Timo, I'm interrupting, but there. Okay, I screwed up apparently. Sorry. There is no sound. Okay, let me check. Ah, okay. Now they say that it's okay. Sorry. Okay. Maybe. sorry that this.
So one could not hear me, or?
Yeah. Basically, our like how many, like 2 or 3 seconds there were no sound. But okay, let's recap fastly.
Okay.
So.
Sure. Like, was there? Did one ever hear me?
No one heard us. Basically, I forgot to give the sound from OBS, and now.
Okay.
Yeah, now it should be there. But okay, let me restart again.
Go ahead again.
Okay. So okay, welcome back again, everyone. Sorry about this small technical issue. So today we are going to be hosting Timo de Wolff. So Timo is my PhD advisor, and we know each other for 3 years now. And in these 3 years, we did some research. Some of them were towards interdisciplinary areas. So he also has a few more researchers in this direction, and So he's also a member of Junge Akademie. So this is another reason why we wanted to talk with him today, because in this organization, which he will tell us a little bit more about in this talk, during this talk as well. In this organization, there are lots of scientists from different areas, and they come together and they try to do research, and we will see and hear what they are doing in there. So, without further ado, let's start again by Timo introducing himself. So, Timo, you are. Tell us about like what you are doing at the moment, and basically how did you come to this level in your career?
Yes. Okay. So first of all, thanks again for having me tonight. Yeah, as Oğuzhan already said, my name is Timo de Wolff, and I'm a professor for applied algebra at the Technical University of Braunschweig at the moment. So maybe I quickly first summarize like stations of my career, how I ended up there, and then we can talk about certain things in further detail if we want to, and then maybe say a little bit about what I do. So I studied in Frankfurt in Germany, the Goethe University. So actually, I started with studying philosophy, but then after 2 years added mathematics as a double major, kind of. And but then finished mathematics first, like it was still like a diploma. And then at the same place and in the same group with my advisor, Kirsten Theobald, I started a PhD in mathematics. And like on the way, finished with this philosophy studies. And so the PhD was on a topic that's like the specific topic is called amoebas. The broader topic is tropical geometry. So that's a rather pure area, which is like any intersection of algebraic geometry, combinatorics, and a little bit of functional analysis. But so this sounds, of course, very pure. Most of this was, I guess, but I mean, the group had, and my advisor had like various interests, in particular with respect to certain areas of optimization, semi-definite programming, etc. And we did quite a few algorithmic or, yeah, let's say algorithmic topics and problems with regard to this object. And so I also learned this part on the side. Like, I mean, as in particular at the end of my PhD time, I started to work on non-negativity, polynomial optimization, real algebraic geometry with another PhD student, Sadiq Iliman, who was a PhD student at the time in the same group. And yeah, so I graduated in 2013, then went for a 1-year postdoc to Universität des Saarlandes in Saarbrücken. It's like, if you don't know where it's located, it's relatively close to the French border in Germany. In the group of Hannah Marklich, so continued there as a postdoc. And then I went to the United States for 3 years to Texas A&M University. Then from, let's see, 2014 to 17, working there with Frank Sotia and Maurice Rojas as my mentors. And then in 2017, we returned back to Germany, to TU Berlin, with where then I started an Emmy Noether fellowship or Emmy Noether group. And then in 2019, moved from Berlin to Braunschweig. So these were like roughly the stations. And I mean, to catch up a little bit on what I do, so it's essentially that this real algebraic geometry, non-negativity, and polynomial optimization, which I already mentioned, started to move more and more into the center of what I was doing. So starting basically like really during this first postdoc year, we wrote 2 articles about this area, which introduced certain new certificates of non-negativity, which kind of opened up a certain area to work in. And so this was again with this collaborator I already mentioned, Sadiq Iliman. And then we like further developed this area. Initially more on the, let's say, on the theoretical real algebraic side, I would say, and in the combinatorial side. But then it relatively quickly became clear that, I mean, because you really want to solve polynomial optimization problems with that. So you need to also think about, like, first of all, the optimization questions. How do you formulate this? What are the correct optimization problems? Then you want to start to think about algorithmic problems. Like, can I do this, like, kind of in an effective way? And then at a certain point, of course, I mean, you start to write some code, right? I mean, then you think about applications as well, like what you can solve. And so, I mean, so in this sense, it was like kind of a gradual shift, right? I mean, I started to think about more applied problems, I would say, or yeah, let's keep it like this. So, like, about more applied problems or questions, probably mainly during the time in the US. But we did not really at the time work on something actual applied. And I would say, like, actually, I started this somewhat in the Berlin time. Then, I mean, we did it in the group, but I mean, there were also some projects with other collaborators from other groups that I was involved in. Yeah, and I would say, of course, this is all. So you already mentioned Junge Akademie, so this made a big change. So, like, I started Junge Akademie a little more than a year ago, and so, of course, I'm like very early in my career, and I'm holding this tenure position only like 1.5 years now. Of course, so other people have worked on applied areas much longer than me. But I would say now there is a certainly, like, within the last 1.5 years, there is a stronger shift towards interdisciplinary in what I'm doing, due to, I mean, this extra that comes from Junge Akademie now. Plus, I mean, I find this very interesting. Like, I mean, I would say, like, that I'm moving myself more and more in this direction also in mathematical research. At least I did in the past few years.
I see. So I have like before we discuss a little bit more about Junge Academy. So maybe I should ask you a few like questions that I also wonder as your PhD student as well. So
Okay.
like how would you describe an applied mathematician? And like so like when I was doing my bachelor's degree and everything and around my master's, it was always, you know, like being an applied mathematician was always considered, or at least imposed to me as, you know, going into the dark side, or I don't know, usually it wasn't something good. Like at least I had this perception about the applied mathematics for some reason. But I also would like to hear, what were your thoughts about applied mathematics throughout your education and everything? So did you, like, first of all, was there something like this in Germany among the students? Like it was, was there a distinction between, oh, you're an applied mathematician and you're a pure mathematician or something like this?
Yeah. So, okay, let me try to answer in various ways about this. So, like, first of all, of course, traditionally it's true, right? I mean, that there is, like, this notion of, like, there's pure mathematics and there's applied mathematics, like, if they were two distinct things, maybe. And but I would see this more like a certain spectrum, right? I mean, you can like, rather than a binary choice. During my studies, I think so. I guess I did not experience this so much during my studies, because, so maybe this was just in terms of the lectures that I was listening to or so. But I would say probably at least I listened to more lectures on the pure side than on the applied side. And I would say that also, I mean, I'm not sure whether it's fair to say that there was, like, at the time, there were more people in pure areas, but it's not so important. Like, at least I would say I rather listen to just these pure lectures, etc. I mean, being before I started PhD, right? And so I think I did not think so much about this application part of it. Certainly this notion of, like, distinguishing between pure and applied existed, but I don't know whether it was like so strongly as you described it in terms of like the one is the bright side and the other one is
I
like
mean,
the
maybe
dark.
I was
No, no.
maybe I was living it too passionately
Yes.
within myself, probably.
But certainly, I mean, like overall, I guess this notion exists still nowadays in certain places. But on the other hand, I mean, I would say I don't like this term applied mathematician so much, because I think it's like first of all, I mean, there's lots of applications you can look at, and there's like lots of things you can do. I think this is kind of a too general description of a subject. So this is number one. And number two, I mean, maybe I'm not trying to answer like what I think what really, let's say, an applied mathematician is. I would say like how I would like how I like applied mathematics, or how I enjoy it. And I think, I mean, the way for me to enjoy it is, of course, that you have a problem that, or a bunch of problems, which is somewhat motivated from application or from other sciences, say, right? Or maybe it's like, it can also come from mathematics, but let's say for the moment to make it easier, it comes from some kind of applied area, some other science. And then you try to understand what is the mathematical structure in it. But then, I mean, it only becomes interesting if you add something which you would traditionally call pure mathematics, right? I mean, it's not just, at least for me, it's not so much about like, oh, okay, like here's this application, and now just we like download this and this software, and we push the button, and then it's solved, and we are happy, right? There's not so much to learn from it. But I mean, it's just like much more interesting if there's a certain mathematical structure to find in, and then to understand, and eventually, if things go well, not only understand them, but to somewhat use them to have an impact on the original question that comes from, let's say, the applied side or the other sides. So at least that would what would be for me the ideal outcome of a typical project that I would enjoy. Yeah. So does it answer the question?
Yeah. I mean, I especially liked your answer in the sense that you said that, okay, there is like not one type of applied, like there is not one notion of applied mathematician, because this is so true. I mean, it's really like depends on like, I mean, you can, like, as long as you have the mathematical tools, you can be doing whatever you like. But the thing is that I don't know, there is too much tools and there is too much knowledge that you have to grasp. And if you want to call like one person a general applied mathematician, which is like, of course, which starts not to make sense at all. But so here is a remark from Iran Portakal. So she said that I heard and felt many times the following: if you don't do pure mathematics, you don't attend to real and important problems, which is so not true. And I also like, yeah, this is like, okay, I'm ashamed to say that if you told this sentence to me when I was in undergraduate second year, I would be like, yeah, of course. I mean, because I don't know, I always as I said, I'm ashamed still of this. But now I totally see what Irem is saying, and this is totally not so true. I mean, like even, I mean, you probably know better than me, like how applied mathematics changed the course of Germany. I mean, also like, let's say like how applied mathematics changed the course of like last century in general, with all of these applications on, I don't know, like from warfare to computer to, I don't know, like everything that we do at the moment is basically based on like applied mathematics, and calling this nonsense and not useful is, I don't know, just bogus.
Okay, yes. So let me make a quick remark first. So I mean, okay, it's true, unfortunately, that warfare is often a motivator for certain applications, but so there are also good things. Okay,
I said internet.
So let's exactly. So let's focus on that.
Definitely.
No, I mean, the way I would like to answer the question is, I mean, of course, so I already confirmed, right? I mean, this notion certainly traditionally is out there, and certainly it's still out there about like I don't know, the one side does the deep problem and the other side does the interesting problems or whatever, right? I mean, or the other ones are the only ones who can gain funding, or like whatever it is. But I mean, I would just try to give the answer in a way of saying, like, I at least personally, I think we should stop fighting this fight. I mean, there is mathematics, period, right? And I mean, it's not that one area is the good one and the other one is the boring one, or is so there are important and deep problems in various areas of mathematics. It is not, in my opinion, that one can simply draw a line and say, this is pure, this is applied. Although, I mean, like, certainly there are certain topics which are very pure, and there are certainly various topics which are very applied. But I think there, as I said before, I think it's a non-binary thing. And also, I mean, I think it depends actually on the particular thing that you do. And then may the community decide whether this is important, or whether this is deep, or whether it's not. But I mean, I think especially if we try to take a look at science in total, then I mean, various other areas of science tend to have much larger communities than we have in mathematics. So I think we should not start to fight each other along these, like, who's doing the greatest math. I think mathematics is great in total, and we should not. We should rather try to talk more about the different areas and the connections and what they can be useful for, than trying to, I don't know, like, fight each other about, like, what kind of problems we work on.
Definitely, definitely. I really like this way of thinking. I mean, now I really like this way of thinking. I mean, beforehand, I was in totally different roles. But you said something really nice about, like, entirety of the science. So we were already, like, discussing you about this time to time, but I also want to ask this question here as well. So, like, how would you see mathematics in the sciences? Like, so we say that, okay, like, we always say, like, of course mathematics is everywhere. Like, we should, like, so. I mean, on the other hand, like, in every science faculty, we find mathematics department or something like this, or like some equivalent of this. But on the other hand, there are like, really certain differences between mathematics and the science when you think about it. So, I mean, first, like, one of the first big difference is basically the experimental side. Like, we in mathematics, we do not directly follow the scientific method, in the sense that we don't do experiments usually. But do you think that, is it still, like, okay to call mathematics a science, or is it more like, a sidekick to the science?
No, certainly it's a science. I mean, that for sure. Like, I mean, okay, that's a very complex question, and let me try maybe before. So I will not answer this. Like,
Yeah, I
I
mean,
can
yeah,
already tell
definitely.
you,
Yeah.
I will not answer
Okay.
this. But let me try to break down a few aspects of it, and then maybe we can discuss it a little bit more. So first of all, I mean, you asked about, like, how to see mathematics in the realm of the total sciences, and I mean, in a certain sense, there I would. Like, first of all, one should realize there, of course, I mean, it's not only about, like, maybe you asked this question about, like, okay, like, here mathematics is different from, like, the typical way of, like, say, for example, natural sciences, in terms of, like, performing experiments, scientific method. But of course, I mean, like, science is much broader than that, right? I mean, let me start with that. I mean, certainly natural sciences are all over, they are great, and I like them. But I mean, we have literature, for example, right? I mean, or social sciences, and in they, like, or let's say people who study law, right? I mean, and in this sense, I mean, where also, like, the way science is performed there, I mean, if you compare that to maybe, like, a big lab in engineering, then maybe the difference is even like much larger than what we discussed between mathematics and the typical natural sciences, let's say, in a bio lab. So in this sense, it's a little bit. I mean, like to me, this sounds a little bit like on a larger scale, the kind of the same discussion that we had before with the pure and the applied mathematics, right? Let's not try to go ahead and say like my science is the true science and the other science is the wrong science, right? I mean, we are all scientists, and different areas have different methods to solve their problems, to attack their problems, to discuss their problems. They have different ways of working, of publishing, of like what is common in their communities, etc. They're very different languages, and so in this sense, I think, I mean, we often, if we are working scientists, we are very much like thinking in like what is common in our particular field. And then there is, so it's very human and natural, right? I mean, you think like, yeah, this is like how science works. But I think it's very helpful to try to see it from a broader angle, first of all, and try to say like, okay, I mean, try to speak to other scientists and ask them, okay, what do you do? How do you do that? Right? I mean, what does it mean to do a PhD in your field? What does it mean to publish? Do you publish books or do you write articles? Or I mean, and then I mean, of course, you might even go broader and say, what's about people who are in art or something like this, and like how much does it differ from science, for example? So I think this is one aspect. The second part, I mean, you were asking about like scientific method in particular. And here, I think it's, so first of all, I would think this is changing in mathematics in one way. So that I think is very important because, I mean, yeah, so I at least I told you before. So I always feel, if I see what I'm doing and if I see what people have done like 100 years ago or maybe 120 or 40 years ago, I feel like I would be completely lost in my research if I had not the ability to use computers. I feel like the people at that time were incredibly smart, much smarter than I am. And so I feel like I'm lucky I have this advantage, really, I mean, in terms of what we are doing. But I mean, to explain this a little bit further, sure. I mean, like the fact that we can code things nowadays and that we can use computers for I mean, computing examples, for example, on a large scale. This helps a lot, I feel like, with mathematical research. And this is actually pretty close to what is traditionally thought of scientific method, at least in my opinion. Because, I mean, what do you do, right? I mean, you perform experiments, you see a pattern, right? You see a certain behavior, and then you go back and you ask yourself, why is that there? And I'm trying to explain. And if you perform mathematics in this way, then, I mean, it's kind of very similar, right? I mean, you see a certain pattern appearing and you ask yourself, why does it happen? Okay, and then we have like this additional feature that we can prove things. And then, of course, I mean, it becomes very quickly like very, very fundamental and about like what are maybe like if you want to go in this philosophical direction, right? I mean, what are mathematical objects, etc., etc. And yes, so thanks to Gödel, we kind of know that we probably not get to the bottom of this. But I mean, I would say at least for daily work, as a like basically being as a working mathematician, I think this is not so important. I think we have a common understanding and solid way of working in terms of proving mathematical theorems, and there is little dispute about like what we consider a proof and what not. And then everybody who's then a working mathematician performing research, I mean, will be, okay, this sounds very negative, but let me still say it. So like will be held accountable by the scientific community, right? About his or her claims. So in this sense, yes, it's like nice and interesting to have these philosophical discussions, but I think, I mean, for the actual daily work as a mathematician in research, there's no problem, and you can completely avoid this without feeling bad. As long as-
So yeah, I totally agree with you in the sense that like nowadays like how people understand experiments in mathematics is changing definitely, and we also did a couple of works towards this direction about like doing experiments with these objects that you don't know, so that you will get some idea of it. And I think yeah, this is like quite similar in the sense that like in the experiments that people are doing in let's say in a research lab or something. But I think like how we proceed, like how a mathematician proceeds with his data, like this is very different. Like what you do with your data as a mathematician, okay, in the end the ultimate goal is the same, like to get more information about the stuff that you don't know. But in mathematics, just as you said, there is some like procedure that you call proof, then you try to prove stuff with the data that you have, instead of I don't know, like instead of showing that. I really don't know what they like how they prove stuff in a lab, but like they probably tell that, I don't know, like here is the data, here is the statistics of it, and there is probably a there is not probably there is a established statistical theory that enables you to tell some deductions that lets you do some deductions about your data probably. But what we do after this, like, so do you think, like, first of all, do you think that in mathematics, like, is it like, can one do stuff with just the statistics of his or her data? Like, does this mean anything in terms of a mathematical study?
So first of all,
So, like,
I mean,
let me maybe
okay.
rephrase the question a little bit differently.
Yeah.
Okay, this is like some extra question, but I think we should have some time, so it should be fine. So, like, let's say that like you have all the results of a mathematical experiment, and you know tons of statistics, but you have no idea about the date, like where the data is coming from. Like, let's say that it's an experimental thing from algebraic geometry. So do you think that you would still be able to do mathematics with just this?
I'm not sure whether I fully understand the question, but let me still try to answer it. So, so first of all, I mean, okay, actually, I want to make a comment before I answer it. So, like, first of all, I mean, I just said something about like nowadays we have computers and we can perform experiments and so on and so on. Like, you know, so of course, I mean, don't get me wrong, right? I mean, there is nothing wrong, of course, with a traditional approach of doing mathematics, right? I mean,
No, of
if
course,
you
yeah.
don't like computers, for example, and it could be then, and you say like, my math is pen and paper, that's completely fine and valid, right? It's not what I'm normally doing, but I can only speak for myself, right? I cannot say that this is the right way of doing it. Okay. So having said this, now you asked about like what would happen if one had like a lot of data about a problem in mathematics and maybe some statistical theory, and the question is what comes out of it. So I would say, I mean, on the one hand, certainly this can help, but it doesn't have to, right? I mean, normally, yes. I mean, I would think like often I would probably approach a problem even this way and try to do that and to understand something of it. Because I mean, so kind of, I would say like the punchline for me when doing mathematics and trying to prove something is, I mean, there is a fantastic feature in the mathematical universe is that basically everything happens for a reason. Yeah, so there's like the overall goal is always that there is structure and there's pattern, and you try to find it and to see it. That's step number one. And step number two is like once you believe you saw it and you found it, then you want to go and prove it. But these are two steps. So in this sense, I would say performing the experiments and having the data, etc. This is helping with step one. But it does not help with step 2 normally.
Yeah,
but I mean,
if you are lucky.
Yes, there are some specific exceptions maybe where you, I mean, like we know that there are some computer-assisted proofs for certain theorems and so on. That's not what I'm talking about. But I mean, in the way you just described, right? I mean, I'm running a bunch of experiments and want to try to maybe like see something from it. But again, I mean, we were speaking on a very general level, and I mean, I feel that this maybe a little bit, yeah, I would even almost say inappropriate to do it, because I think it depends very much on the particular area, on the particular problems, etc. you're looking at. And it's not that there is like the one method that can be applied to all sorts of mathematics and that are the useful way of doing it. So I would, in this sense, also be like really take all what I said like with quite some caution. I mean, in this regard.
I mean, I'm also trying to follow the chat at the same time. So there is a really nice discussion about applied and pure mathematics. people really, yeah. But yeah, like I mean, there is like lots of like input from Turku, Paul, Iram, but yeah, they had a really nice discussion in parallel. But we can check it later as well. And also, okay, so without further ado, like let us maybe come to like one of the most important subjects of this talk, the Junge Academy. So we mentioned that you are a member of Junge Academy and everything. I give a really short introduction of what it is. So maybe you can like shortly tell us what is Junge Academy and how did you get involved with them? Like how did you hear them?
Yeah, sure. So essentially, Junge Akademie, it's like, if you translate it to English, would be like German National Young Academy. It's basically if you want to say, like, it's kind of the version for young scientists of like two particular academies in Germany. That's the Berlin-Brandenburgische Akademie der Wissenschaften und die National Academy of Sciences, Leopoldina. So, and essentially here, I mean, in various of these, let's say, very traditional senior academies, this is like that scientists at some point become appointed basically for a lifetime. And in Junge Akademie, it's a little bit different in terms of the procedure. It's like Junge Akademie always has 50 members from all sciences in Germany. And so it's always 50 because you become a member for 5 years. So like every year, 10 people leave and 10 new people join. And so in this sense, Junge Akademie remains young. And essentially the idea of this institution is, I would say, two things. So the one is to perform interdisciplinary research, and the other one is to do, I mean, very roughly speaking, you would probably say like do outreach. I mean, to have an interaction of like science and society in various ways. So but that's kind of what we do. And yes, so we are, the members are, as I said, from all sciences, also actually from art. It's not science alone. We have various artists. Essentially, from there on, it's the way you fill it with life is like up to you. I mean, it's not that you join and say like, okay, now you have like this and this duty, right? I mean, it's more like, I mean, the overall academy has a budget, and if people say like, okay, I want to do this kind of interdisciplinary research, or I want to do this project or something like this, they basically bring up the ideas, they discuss it with the other members, and eventually, if they want to start a project, we meet in a plenum 3 times a year. So you basically, you write like a little proposal and you bring it to the plenum, and then it will be discussed there. And you kind of need approval from there to, I mean, at least if you want to get some funding. But I mean, of course, then on top of that, you can and you will do what you want. So it's like very much it's like living from the input of the members, and also of course I mean then from the ideas and from the interaction input. So these plena of course are very nice because this is like a joint meeting of kind of everyone. But on the side, there are like various events that are running, and then this is like happening on different levels. I mean, there are the individual projects, but we have like some kind of working groups that are like, yeah, not permanent but long term about certain areas. So, for example, in one about artificial intelligence, and one about like environment, and some others. And
I see,
so,
but these are quite broad, like in the sense, like
yeah, yeah. So there's a bunch of the members are like of the members of the academy or members of in these working groups, and then you have like running projects, which is maybe like smaller, and then you have like these more small level, maybe one-time event things and so on.
I see.
So you have like kind of the spectrum. But as I said, so the overall idea really is to do interdisciplinary work. I mean, both in terms of research and in terms of outreach. Yes, and of course, so like we brought it up earlier, and we mentioned it because of course this for at least for me was it's really broadening the horizon first of all, but second also of course a great opportunity to do a more interdisciplinary work.
Yes, definitely. Because like it is really hard for someone to just say that, okay, now I want to be interested in physics and let me go and find a physician and start talking with him. So, okay, yeah, you can always, of course, do this. I mean, you can just send an email or whatever, but it's not like, I don't know, like coming together in a natural way in such an environment, for example.
No, it's complicated, right? I mean, I mean, okay, at least I can only speak again like from the mathematics point of view, and also maybe just from my very narrow experience that I have, right? But I would say like normally most of the time when we are doing mathematics as researchers, we like do math, period, and maybe we do it together with other mathematicians. And or maybe sometimes we are in a particular very applied field. I mean, this is also of course a standard thing, right? I mean that you know like your research is like it's motivated from this one particular problem, which is maybe very general from this area, so problems for physics, right? And then I mean you're doing the mathematics around this in order to perform to improve this problem. Yeah, that's completely great. Both of these things, of course. So for me, I would say, I mean, the interesting thing, at least how I try to do this kind of interdisciplinary work and that I enjoy is to see like, okay, like not to just choose one application, say like this is the one application or the one area I want to work with it, but to rather like look around and see what is there, and then to see like where is algebra appearing in these different areas, and how can we make it visible, how can we make it useful, and then but then maybe the particular collaboration is just one paper or two papers, and then it might not continue for entire careers. But yes, so normally I think this in general, this is of course hard, as you already said, because like it's hard to, first of all, normally people don't meet from different areas so much, not naturally. We have our own conferences, our own communities. It's hard to get this interaction started. And second, even if we do, maybe even, I don't know, but it's a problem which is as big, I would say, is we don't speak the same language.
Definitely, yes.
Yeah, so it's like, it's hard. You need to sit down and you need to talk a lot, and you need to start to translate, because you will even, I mean, if it's in areas that are relatively close, it's very hard and takes a lot of time.
No, even in mathematics, this is sometimes a big problem. I mean, there are mathematicians that really doesn't understand each other, like each other's study areas.
Yeah, certainly that's true. But I mean, so let me maybe give another example. I mean, in the course of the past 2 years or so, um, we had we have still a collaboration with someone from theoretical computer science, so which is really an area which you would think is like relatively close to mathematics. And I mean, it is. Like,
It's almost mathematics.
yeah. Well, don't. Right, but I mean, like, yeah,
Just
no,
kidding.
but it's
Just
very
kidding.
close. It's very close, right? I mean, so and essentially, I mean, in this collaboration, it's really about polynomial optimization. So they kind of do really the same thing, and they're citing the same papers and so on. But when we started this collaboration and we wanted to go for the first paper, it took a very long time, really, until we had translated each other's language before we could really start to discuss problems. I mean, I don't remember fully how long it took, but it was hard work to get this done. Once we had it, it was great, right? I mean, then when you have a common understanding about what the other person means, about what the problem is, and what is interesting for the other party and why, then it becomes very, very rewarding in my experience, and then also very fruitful and potentially very interesting. But yeah, it's still same. It's hard, right? I mean, you need to really invest.
Definitely. And so like how was your first like interaction with Junge Academy? So like what was the reason that like made like how did you make your mind to apply there? I mean there are lots of options that you can go for, and like first of all,
Well,
how like how did you like? Was it in your mind for a while to apply for Junge Academy, or was it
yeah,
something like you realized that it exists and then you said, "Oh, okay, maybe I should go for this"? Because I mean, like,
no, no,
yeah,
no, no. It was in my mind for quite a while, actually. I don't remember exactly from like when I first learned from it, but I knew about the existence for quite a long time, somewhat. I guess I probably saw some previous member in mathematics when I was, I don't probably a PhD student or so, in some talk probably mentioning it. I guess it's like I have a like blurry memory of this, but I mean at least I knew about it like uh, for like in quite some detail about like
I see.
3 years before I applied.
Hmm.
And then no, it was like very specific, right? I mean, it's just like the way it goes. It's like always in one basically every other year. In one year, it's like you can apply or everybody can apply. It's
But
open, and then in the
maybe a question in here is that do you have to be a German citizen? I guess you have to be like, or is it
ah
enough if you are like
um,
doing your research in Germany?
oh, that's a I oh, that's a good question. I'm not 100% sure about this, but I mean, okay, like if you're interested, right? I mean, there is an open call for application this fall. So if you
Oh,
go to
okay.
the website, you will find
Okay,
that.
yeah, maybe, yeah.
I would guess probably okay. Let me say
Hmm.
this. So um, lots of young academies now exist in other countries too. I mean, actually, so this kind of thing was happening initially in Germany. So this kind of young academy, but now I guess in various other countries there are some too, and it's growing.
Hmm.
Yes, but I mean, for me, it was really that, I mean, maybe rather from the motivation that I wanted uh, to work more interdisciplinary for quite some while. And also, I mean, um, do some, yeah, on the one hand, do some more outreach things, and then do it it felt like at a certain time when I was working on mathematics that these things do not really have so much a direct impact on the ongoing world
Hmm.
outside.
Hmm.
And I really, I mean, yes, so back then and now I thoroughly enjoy doing mathematics and proving abstract theorems, but I I think I also wanted
to give back, also like give back to humanity in some way. I mean,
well, I mean,
or like not in humanity,
no,
but
no. I mean well, I mean, we do this with mathematics too, right?
okay, yeah,
I mean,
definitely, yeah, of course. I always say this, like, okay, yeah,
no, it's
definitely,
true.
yes, definitely, yes. This is happening also in mathematics, but I wanted to say it like in a more, I don't know, like outreach is something else after all, of course, like.
No, but also, I mean, like maybe how be able to do projects with more direct impact. Of course, you
Yes,
don't have to do it via Junge Academy, right? I mean, you can
definitely.
do it, and but I mean, it felt like a way. I mean, why I finally decided.
Hmm. But there is actually one question that came to my mind, like when you were talking about the hardships of doing multidisciplinary research. I mean, we didn't specifically talk about this, but you said that like one of the problems is the language, finding a common language.
Yeah.
So like here, like, so first of all, like how do you think that this is handled in like in young academies like Junge Academy, or like at least how it is the case in Junge Academy? So first, like there are several projects now that you have been involved in. So like two questions, like how do you think that this language problem is getting handled in Junge Academy, and second, what is your role as a mathematician in this in this like solving or like in such an environment?
I'm not so I'm not sure whether, like, let's say if people perform interdisciplinary research, then I think, I mean, and it doesn't matter whether it's in an environment like Junge Akademie or somewhere else, but just people find together and say we are from different areas, let's do research together. I think it's in the end of the day, it's probably, at least from my experience, which I already said, right? I mean, other people might correct me and might have experienced something completely different, but at least from my experience, it always comes basically down to probably two things. The one thing is what I already mentioned. It takes time and quite an effort to understand the other involved sciences and to understand their languages and to work on that. And second, of course, it also really, I guess it requires some open-mindedness and some curiosity, right? I mean, that you really say like, okay, I mean, like, what are you doing? And I really want to understand, and I find it interesting, and I would love to understand it better, and I would even more enjoy if I could contribute something to it, right? So I think this is, of course, like very important. Yeah, and in the end of the day, it's probably like these two things that have to be overcome in any environment where you want to do this. And so the second question, I think, was what is the role of mathematics in it, or what is like my role specifically?
Yeah, I mean, of a general mathematician, not yours specifically, but you can also, of course, tell that if you have a particular experience in this direction, of course.
No, again, I would say it depends a lot on like with whom you are collaborating, right?
Definitely,
And
right?
so I mean, one of the things that maybe is a nice thing about mathematics is really that, I mean, you said it earlier, it appears like in a broad range of sciences, like almost all sciences. And it's, so in this sense, maybe we might have, as mathematicians, in a certain sense, although it often says like, okay, we are doing something very abstract and we are doing something that's like far away from the real world. I mean, of course, like from an outside point of view, is it on the one hand true, but on the other hand, I think this is just really half side of the story, because the other side of the story is that mathematics is really everywhere. And so in this sense, I find it, I mean, I'm very happy about my choice of my field in this sense, because it's always, I mean, like assuming that you have the right person and the right problem and so on. But theoretically, I mean, as mathematicians, we can talk to engineers, we can talk to natural scientists, we can talk to people from life science, we can talk to people from architecture, right? I mean, so the possible range of topics, I mean, like basically goes through almost all sciences, right? I mean, if you
Definitely.
start to have a conversation, at some point you will find a connection to mathematics. or you have a good chance at least. So in this sense, I think actually mathematics is great for interdisciplinary research.
Definitely.
But let me also make another comment maybe about this. I mean, which I find is important if one is interested. I mean, like in doing something like this. Important point really is that you have to have something to offer, right? I mean, it is not enough that you just say, well, okay, I'm a mathematician, and now let me. I mean, like especially if it comes down to something that's, for example, very computational, right? If you then say like, yeah, okay, like I'm a mathematician, let me solve, like let me do the computation for your problem. Then rightfully so, probably a lot of people in other sciences will say, well, thanks, but I can do this myself, right?
Yeah, if
Maybe
there's
also
already a
mathematics,
software to do
right?
it.
I mean, and they have software too. And this is like, it's not that, I mean, everybody is waiting for the mathematicians to come and to save them, right? I mean, so in this sense, I think it's very important to say, like, if you like applications, yeah, sure. I mean, you need to be open-minded and you need to be interested in that. But it also is very important to learn solid mathematics to have something to offer that
Definitely.
might be helpful.
Definitely. I see. So we are on the 55th minute. I don't know if it's the right way. 55th, right? It's hard to say 55th. Okay, but we should maybe probably like slowly, wrap up the today's talk. But maybe as like one of the last questions, I can maybe ask you about like what would you recommend? Like, so we have lots of people listening us from various levels of research, from undergraduate to masters to even higher, like PhD. So it's a hard question to answer, like to give one answer probably. But I would like to ask, like, what would you recommend for those people who wants to go into multidisciplinary research? So as a mathematic with a mathematics background, let's say, like
Yeah,
let's
sure.
try to put it a bit more in a structured way. So let's say that I have my undergraduate diploma, or I have my master's diploma.
Yes.
What should I do?
So, well, actually, okay. Let me try to answer, but let me actually go a step back. I mean, because I mean, there might be people who are even earlier in their
Oh yeah,
career, right?
exactly.
Might be students. So as I said, I mean, let me stress this at the end. So I think it's very important, even if you say like eventually I'm interested in doing something applied, do get a solid mathematical education, and that in particular includes the theoretical parts. I mean, it doesn't have to be algebra, right? I mean, maybe if you like, that's just me, right? If you don't like algebra, it's great. If you that's completely fine, right? I mean, if you learn, I don't know, like solid combinatorics, or you learn solid analysis or something like this, it's completely fine. But try to learn theoretical foundation of our subject to have to build on, right? I mean, this is like really what all mathematics builds on, is like these fundamental building blocks of theoretical mathematics.
So knowing your mathematics is, like, of course, the
Yeah,
key.
it's important. Yeah. So then, and number two, what I would
So
say, I
maybe,
mean,
okay, before
yeah,
you go to number two, like maybe I should also remark in here that, like, this goes back to the to our first discussion about applied mathematicians and stuff like this. Like, so the conception of applied mathematician doesn't know mathematics, like, so this is again comes up in here. No, like they should know it by heart actually. I mean, just as you said, like, it doesn't mean that you're applying mathematics. You shouldn't
yes,
be concerned
no,
about knowing you should
I
actually know
mean,
it.
plus it's like, even if you're, I would say, okay, you should always do this in mathematics. Even if you don't want to go in application, so it's like always true, right? I mean,
Exactly. Yeah,
the
that's
correct
part.
first step is always
Exactly.
try to get a broad, solid, foundational education of mathematics. And like, for example, like when I was a student, and also like during my PhD times, but especially as a student, I missed out certain areas, and I bitterly regretted this later, because it becomes very, very hard to close these gaps, because it takes a much more effort. And so, especially when it comes to these very foundational things, where you feel like, okay, this is like very abstract, this is very far away from it. Like, I just want to do machine learning, right? Or I just want to, like, whatever, just want to do optimization. Why do I have to learn this stuff? Like, please still, like, try to get as much as possible. But then on top, I think it's very good kind of early to try to gain. I mean, first of all, I think it's certainly helpful to start to do some coding, especially mathematical coding. So in an appropriate language, it is not so important which one. Do something that you feel comfortable with. And I mean, if you don't know really what to code, but I mean, try mathematical algorithms. There are plenty of them. Try to do that and try to understand mathematical thinking. Algorithmical thinking, right? I mean, so there's at some point probably, I mean, you have to compute a problem, and that is a different thing than just proving a theorem or having a theoretical solution to something. So I felt that at least I try to do this with the students in my group on different levels. That I think it's very helpful to train algorithmic thinking and to do coding. And then, of course, I mean, and that I guess is like true also for now. A lot of the things I'm saying applies also to later career steps, especially for PhD students, right? I mean, of course, you need to be. Well, it's great if you're open-minded, if you try to learn about like other areas in science. And there's of course various ways now to do that. For example, I mean, I'm sure there are some other nice YouTube shows that you can attend, right? I mean, about like other sciences and so on, and also about potential applications of mathematics. If you want to go on with it, I guess like as a PhD student, it's also important that if you already know that you want to go in such a direction, right? I mean, let's say you're starting your PhD, you're determined, you say like, yes, I really want to do something that has some like real world application or something like this. Then of course it's very helpful or maybe even mandatory to find an environment, to find a group, or at least like a grad school that allows you to do that and that would support that. It's maybe not a completely necessary thing, but of course it's very helpful. Like, I mean, if you're thinking about starting a PhD in some area, in some place, then especially I would say, for example, in a context like Germany, which is like very group focused, then the particular group where you're in is having a lot of impact on the kind of research you can do. And that's true in other places as well, right? I mean, maybe a little bit less strict, but overall it's still true. I mean, like if you're in a grad school in the US, for example, right? I mean, it would be very strong. And I mean, maybe for the time afterwards, let's say you're a postdoc or beyond, then of course at some point, this is the time in your career when you would start to do own projects. Maybe you do it even at the end of your PhD time, depends on your advisor, depends on you, depends on the group, depends on the area, etc., etc. But there will be a time in your career when you start to do own projects in some sense, or at least maybe as a first step, you do projects without your advisor. And then at some point you do it by yourself. And then, I mean, if you take this decision that you want to go in such a direction, that then we go back to the point where I said like, okay, there are like these hardships to overcome. So you will need to get in touch with people, you need to start to talk with them, and or maybe there is someone who can like introduce you or something. This would of course be even better. But again, right? I mean, don't expect that this if you don't already have such a connection coming out of either your PhD group or maybe someone else in your community you've been working with, who's like getting you into this. If you want to do this by yourself, certainly this is generally speaking rather challenging. For example, I mean, maybe I can tell one quick anecdote if we have the time.
No, we have the time. It's fine.
Yeah,
I mean,
okay,
like as long as you are like you have the time, we
as
should
long
also,
as okay, yeah, I have the time. So yeah, actually, I mean, at some point when I was in the US, as I said, I mean, at the time I did not have any, at least to my memory, not any applied really or like interdisciplinary projects going on. I was asking myself how to do that. And then at some point I got in a connection with a professor I think at the time he was an assistant professor in mechanical engineering. So Texas A&M is kind of like is a university with a very strong focus on engineering. So it's agriculture and mechanics. So it's like really an engineering focused university. And so and I think the connection, like actually the professor, so I was a postdoc, so the professor reached out to me actually because he had done some work which was related, I think, to semi-definite programming, and so he like kind of realized, oh, there's this guy in the math department who does something like that, right? So it was like very nice. And like he sent out an email. They had a great speaker at the time, like invited Yürük. If you do convex optimization, you know probably the book Beuten und Berge. So he was giving a talk, and so like then there was a way to chat, and then we continued the discussion a little bit afterwards. And for me, this was like very interesting and so on. I learned about like some of the problems he has, but at the end of the day, it did not go any further because I guess at the time, at least at the time, and this can still happen today nowadays, but certainly at the time, I did not have any experience, and I did not know enough mathematics as well. And I think he had great problems, but it was, I think I was just not able at the time to really contribute something. So it was still a good experience, but I mean, in this sense, as maybe like the moral of the story is somewhat, I mean, don't be afraid to just try something, and don't be discouraged if it doesn't work in the first or second try. And you can still gain something from that. You can still learn something from that. But I would also add on the other side, I mean, be aware, so in particular, like speaking to PhD students and postdocs, be aware that you still also have to follow a scientific career, right? And I mean, as you all know, it's a very competitive environment, and the currency overall is articles, right? We are all aware. So, and of course the quality, not only the quantity, but so don't, I mean, I don't want to, like, it's like, it's a little bit like this thing, right? Where like maybe somebody says like, please don't try this at home, right? I mean, so like be a little bit careful is what I'm saying, right? I mean, don't put like all your energy suddenly in these Hail Mary projects, which maybe like will not really work, because they come usually really with a high risk. And please, I mean, like, do it with caution, do it slowly. Don't waste your very promising and great career because you like heard somebody on the internet about interdisciplinary research. Okay, please don't do that. Okay?
So okay, I see that you don't want to destroy somebody else's career or like without
please.
even knowing. I see. No, definitely. Like this is of course a really really important decision that one has to take during his career to do or not. But just as you said, like one of course has to be really cautious about this kind of decisions, but without trying or without just doing it, there is no other else way to do it. I mean, otherwise you are just going to wonder if it would be nice if you did some like if you did some multidisciplinary research. If you don't do it, I mean.
Yes, I mean, so like maybe like more specific even, right? I mean, especially for people who are in a postdoc phase of their career. And in particular, if you're lucky and maybe you have a contract somewhere which is for 2 or 3 years, then I think, I mean, if you're already in such an area, like due to your PhD time and so on, then it's great, of course. But let's say, I mean, you're a postdoc now and you would like to do something in this regard and you haven't done it before. Then, I mean, I think it's a way to go would be to say like, okay, I will try one project, but I will make sure that I perform like my usual research, right? I mean, at the time you're already a specialist in your particular area of research, so it's important to continue with that. It's important to continue to write papers, and to make sure that your career is kind of like solidly still continuing in this area. And overall, I mean, this is like not even for interdisciplinary research. I would say the postdoc time in particular is a great time for, I mean, as being like growing up researcher who is like already on his or her own. It's a great time to do like some experiments, right? I mean, not in a sense of like interdisciplinary research, but in
Yeah,
the sense of
even
trying
within
something
your
new.
research,
Right?
I
I
mean.
mean, you should broaden your horizon anyway, right? I
Exactly.
mean, at the time, so it's very good to just try something new, and then if you do it like kind of with caution and not just like say like, okay, I'm trying to do something completely different now and I will forget everything I've been doing so far, then if it works out, it's great. And if this one particular problem doesn't lead to anything, then you say like, yeah, okay, I did this like kind of as a hobby on the side for a moment, then, but I still continue with my normal work and in the area where I'm comfortable with, where I'm already an expert, etc., and where I can, with maybe some more with higher probability, come to the point where I will eventually know it outright. Yes. Plus, of course, I mean, on top, maybe if I can make one more comment, I mean, we've been discussing these things very much in the perspective of just scientific research and interdisciplinary research, which, I mean, I guess is the normal way to go. But I would also like to emphasize on the possibility that next to us being researchers, let's say working in universities and so on, and writing our normal papers and contributing to science, of course, there's also always an opportunity to do some outreach work which is related to applying mathematics. Again, right? I mean, these things don't fall from the sky. You have to actively look and you have to do something. But it's, I would say, I mean, it's great for everyone who has the time and energy and who is interested to do outreach work in various ways. And there are various good ways you can contribute, right? I mean, it can be due to teaching, of course, in various ways, or to like, I mean, educate persons about research. But it could also be that you have certain knowledge about mathematics that maybe other people do not have, and in the sense you might be able to apply it in a meaningful and helpful way to have some impact outside of the normal scientific universe, which leads to maybe the next publication or something like that.
Perfect. So yeah, it's been now like around 71 minutes, so I think it's a good time to stop our talk in here. And I once again want to thank you, Timo, for this, for sharing your experiences with us. And I hope some of our listeners got some ideas from your experiences, and hopefully we will have more multidisciplinary researchers in the future. So goodbye, everyone, and hopefully see you again in one of our next talks.